Hello friends, myself R.D. Mahajan presenting my video on partial differential equation point solution of partial differential equation by direct integration. In this video, I will discuss three simple examples on this topic. The first one, solve partial differential equation dou 2z by dou y square is equals to xy. Watch the video up to end. Here given is dou 2z by dou y square is equals to xy, second order partial differential equation with z as dependent variable and xy two independent variable. Therefore, first step is we have to integrate this with respect to y. Integrating with respect to y, we get integration of that dou 2z by dou y square with respect to y equals to with respect to y, x is constant term, I can take outside, integration of remaining term with respect to y. As we know that these two operators are inverse of each other, integration and derivative, therefore we get integration of this as dou z by dou y is equals to x, integration of y is y square by 2 and plus constant of integration as f1 of x, where that x is constant term with respect to y. Then again integrating with respect to y, we get integration of dou z by dou y with respect to y is equals to integration of xy square by 2 with respect to y plus integration of f1 of x with respect to y, and therefore we get x by 2 is constant term outside, integration of y square is y cube by 3 plus constant of integration as f2 of x plus here f1 of x is constant term, we take outside, and integration of dy is y, and integration of that dou z by dou y with respect to y is z, and therefore we get z is equals to xy cube divided by 3 to the 6 plus f1 of x into y plus f2 of x is the required solution or a required answer. Second example, solve partial differential equation dou 2u by dou t dou x is equals to e raised to minus t into cos of x. Here u is the dependent variable and x and t are two independent variables, and therefore to solve this, once again we consider given differential equation dou 2u by dou t dou x is equals to e raised to minus t into cos of x as equation 1. Then integrating first with respect to t, keeping x constant, and therefore integration of that dou 2u by dou t dou x with respect to t is equals to here cos x is constant term outside, integration of e raised to minus t with respect to t and plus constant of integration as f1 of x. With respect to t, x is constant term. Then integration of this dou 2u by dou t dou x is dou u by dou x, that is equals to cos x Integration of e raised to minus t is e raised to minus t upon minus 1 plus f1 of x. Then whatever this result, integrating this with respect to x to get the value of u, and therefore both sides we integrate it with respect to x. Therefore integration of dou u by dou x with respect to x is equals to here that minus e raised to minus t is constant term, I can take outside. Integration of cos of x with respect to x plus integration of f1 of x and plus constant of integration with respect to x, constant is t, therefore it is f2 of t, and therefore integration of dou u by dou x is u is equals to minus e raised to minus t as it is. Integration of cos is sine. Integration of f1 of x with respect to x is some new function of x as g of x, and plus f2 of t, the required answer or a required solution. Therefore, once again, the steps are: first, integrating with respect to y, we get this step. That's where to integrate it with respect to x to get the value of u as minus e raised to minus t into sine of x plus g of x, which is the integration of f1 of x, and plus constant f2 of t as the required solution of the given differential equation. Last example, third example. Solve dou 2z by dou x dou y is equals to sin x into sin y with the condition dou z by dou y is equals to minus 2 sin y when x is equals to 0, and the second one z is equals to 0 when y is odd multiple of pi by 2, means when y is odd multiple of pi by 2, means the values of y are pi by 2, 3 pi by 2, 5 pi by 2, like this. At that time the value of z is equals to 0. Here z is dependent variable and x and y are two independent variables, and therefore to obtain the solution we write down the given is dou 2z by dou x dou y as sin of x into sin of y as equation 1. Integrating it with respect to x, we get integration of dou 2z by dou x dou y with respect to x is equals to right hand side integration sin y constant term outside, integration of sin of x with respect to x plus constant of integration f1 of y. Then here integration of dou 2z by dou x dou y we get as dou z by dou y, that integration and that operator dou by dou x get cancelled, we get dou z by dou y is equals to sin y, integration of sin x is minus cos of x and plus f1 of y, we call this as equation 2. Then we use this condition using condition dou z by dou y is equals to minus 2 sin y for x is equals to 0 in equation 2, we get. Therefore, that the value of dou z by dou y is minus 2 sin y is equals to minus sin y into cos of x plus f1 of y cos 0. Therefore, substituting x is equals to 0 here, we get cos of 0. And we know that value of cos 0 is 1. And therefore, we get here, it is minus sin y plus f1 of y. So, other side, we get minus sin y is equals to f1y. Substituting this value in equation 2, that equation 2 becomes, therefore, we get that equation 2 as dou z by dou y is equals to minus sin y into cos of x plus f1y. The value of f1y is minus sin y. And we call that as equation 3. We have equation 3 as dou z by dou y is equals to minus sin y into cos of x and minus sin y. And then to obtain the value of z, we have to integrate it with respect to y. Therefore, integrating with respect to y both sides. Therefore, integration of dou z by dou y with respect to y is equals to minus cos x is constant with respect to y outside. Integration of sin y with respect to y minus integration of sin y with respect to y plus constant of integration f2 of x. And therefore, we get integration of dou z by dou y as z is equals to minus cos x. Integration of sin is minus cos minus integration of sin y, again minus cos of y plus f2 of x. And therefore, we get that value of z as minus minus become plus cos of x into cos y plus cos y and plus f2 of x as equation number 4. And then we use this condition when y is odd multiple of pi by 2. Means first we consider the value as pi by 2. For y is equals to pi by 2, we get z is equals to 0 cos x into cos pi by 2 cos x into cos of pi by 2 plus cos pi by 2 plus f2 of x. This is nothing but as we know the value of cos pi by 2. Cos pi by 2 is 0, therefore first term is 0. Second term is also 0 plus f2 of x. We get this one. And for x is equals to 3 pi by 2. Once again the value of z is 0. Therefore 0 is equals to cos x into cos of 3 pi by 2 odd multiple of pi by 2 plus cos of 3 pi by 2 and plus f2 of x. Once again the value of cos 3 pi by 2 is 0, therefore first term is 0, second is also 0 plus f2 of x. Therefore we have two simultaneous equation in terms of f2 of x, and if it is equals to 0, it implies f2 of x is equals to 0. By solving that two equations simultaneously, we get the value of f2 of x as 0, and therefore substituting that value in this equation number 4, we get the required solution as, substituting the value of f2 of x as 0, we get z is equals to cos x into cos y plus cos y plus 0, and therefore we get final solution as z is equals to cos y can take common. Here it is cos x plus 1. As the required solution or required answer for that partial differential equation. Therefore, in this video, I have discussed 3 simple examples how we can find the solution of that given differential equation by direct integration. In my next video, I will discuss another point, that is solution of partial differential equation by method of separation of variable. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.